Cool. So here's are the 4 equations you need to memorize, write down on your cheat sheet something. You will be allowed a piece of paper, and you could write anything on it. If you write close, small enough, you could write the whole book on that piece of paper. You could use it in the test. My experience as a teacher, the more you write on that piece of paper, the lower your grade is going to be. I mean, you don't, we are going to have a limited time. Just want to, like on the test, there are other classes maybe after we have to leave. So write what you don't want to remember. Write something just so you don't get confused. Yeah.
What would a small piece of paper for the time?
Oh yeah. Again, if you write small enough, you could write the whole book on
So small is kind of relevant. I mean, if I'm the center of the universe,
it. We'll discuss this come test time. You guys could haggle with me, and we'll see how that works. Again, so this formulas is the one we're going to use to derive, to predict, find out where an object lands, how fast it's going, where will it end. If I shoot a basketball at this speed, at this angle, will it go through the hoop or not? This sounds complicated. It's not. Anybody could do this. Okay, finally, I just want to tell you, instead of doing all this crazy stuff, we could have done this using calculus. Does that make sense? So for instance, we have defined A as delta B delta T. And again, your calculus teachers will do that too. So I'm not, you can't blame me. It's wrong, but I'm going to do it. So if I cross multiply, and this is wrong, but it will give us the same answer. And in calculus, they will tell you to do that too. Still wrong. You can't multiply. There's a transformation that will take you from here to there. Who cares? We'll get to the same point. Proper mathematician will be frowning on this, but we don't care, right? And then I'm going to do integration, which kind of I talked about in class. Now, does A depend on T? That's the most important question you always ask. What am I integrating over? How do you know what you're integrating over? You look at this, the D something. We are integrating over T. We are integrating over V. So if you have this integration, what are you integrating over?
Yeah.
That's your variable. Always look for the D thing. Now the next question you need to ask when you're doing integration, and if you don't know how to do integration, don't freak out. It doesn't matter. You'll learn. Is this quantity dependent on the variable? Does A depend on time? Is A change as time progresses? We assume A is constant, so A has nothing to do with T. Does that make sense? So based on that, A goes outside the integration, and integration of dt is T. So meaning you have T to the power 0 in here. Correct? T to the power 0 is 1. So if I want to integrate it, I'm going to 0 plus 1 is 1. Suddenly T appears, divided by 1. Good? Remind you, 0 plus 1 divided by 0 plus 1. There you go. Cool? Again, if you did not do any integrations, you might feel overwhelmed by now, but that is T. Integration of dv, again, this is v0. It's going to be 0 plus 1, which is v, right, divided by 1. And we are going to integrate this from the initial velocity to the final velocity, which means I'm going to substitute the upper limit first minus the lower limit first, which gives me v final minus v initial equals at. And then v final equals v initial plus at. Is that familiar? But I could do the same thing by using integration of v, by saying v equals dx of t. I'm going to cross multiply. This is going to be dx equals integration of v t. Now, we're integrating of, does v depend on time? Yes, so I have to write it in an expression. The initial velocity is constant. This is at. I just found that out. Multiplied by delta t. Integration of x, you get x from x initial to x final. And this would give you v initial t plus t squared over 2. So this is going to be a t squared over 2. Is that an equation that we know? X equals v initial t plus 1/2 at squared. Calculus is really powerful, if you know how to use it.
Marvelous.
Marvelous, if you know what you're doing. So, in other words, I want you to forget everything I said except this. Okay? So, you need to know the definition of displacement, velocity, speed, acceleration, and distance. And these equations, the rest is, I did not just pull out of a hat. I did not make it up. We used logic, and we went through it. And these are valid for constant. And on Friday, this would be fun. We will start taking examples, and you'll see how easy these things are. Cool? So if you don't know differentiation, don't freak out. You'll get used to it. We're not doing integrations yet, so don't freak out about that either. All we need is to remember these concepts. Okay, you guys have a wonderful day. I will see you on Friday or office hours if you have anything you want to ask. Yes.